Hello friends, welcome to Learner's Planet. Friends, this is our third session for linear inequations. In the last session, we discussed the basic concepts of linear equations and the basic rules to solve a linear inequation. Okay, so in this session, let's proceed with some new concepts. And in the last session, I have already told you to go through the session of functions where I have explained the wavy curve method, right? Wavy curve method is used to solve linear inequations. Okay, so whenever you have the problems based on inequations, wavy curve method proved to be very useful. Over here also, I'll just make a quick recap of the same, and let's start the session then. Now let's have a quick recap of wavy curve method. Okay, when we have simple just one expression and some may be greater than 0, less than 0 or whatever. So x minus 2 is greater than 0, that means x is greater than 2, that means x belong to 2 to infinity. Okay, since x is greater than 2, that because of that we have already discussed, we'll keep the circle bracket over here because 2 is not at all included, right? So x belongs to 2 to infinity. Similarly, if x minus 2 is greater than equal to 0, then x is greater than equal to 2, that means x belong to 2 to infinity. In this case, we'll put a square bracket because 2 is also included, right? Similarly, if x minus 2 is less than 0, that means x is less than 2, that means x belongs to minus infinity to 2. Again, we'll put a circle bracket because 2 is not at all included. That means x is the set of numbers which are less than 2. Okay, so x belongs to minus infinity to 2. Similarly, if it is x minus 2 less than equal to 0, then x belongs to minus infinity to minus 2 and minus infinity to 2 square bracket. In this case, 2 is also included, right? So when we have just one expression, it can be easily solved like this. But suppose we have two expressions. Suppose we have x minus 2, x minus 3 is greater than 0. Right? In these sort of cases, maybe 2 expressions, 3 expressions, maybe 4, 5, any number, and some of them are getting multiplied, some of them are in denominator, and so on, right? So we use wavy curve method to find out the solution set for x. Okay, so let's discuss this concept in detail. Now suppose I have an expression x minus 2, x minus 3 is greater than 0, right? And we have to find out the solution set for x. So what you do, you just draw a line, mark the zeros of this equation. Okay, x minus 2, 0 will be 2, because if x minus 2 is there, if I put x is equal to 2, the entire expression will be 0. So 2 is a 0 and 3 is a 0, right? You mark 2 and 3 like this on the number line. Okay, now obviously it should be in ascending order. As you draw a number line, in the similar manner you have to draw this number line and you have to mark this zeros. Okay, now you start drawing a curve from this side. Take the curve over here. On the first 0, change the direction, go to second 0, again change the direction. Okay, this is how you have to draw the curve, right? Now the values between 2 and 3, you can see this is a number line and this curve is below number line, right? So values between 2 and 3 will produce this negative value of this expression, right? Values between 2 and 3 will produce negative solution of this expression. Okay, and the values less than 2 and the values more than 3 will make this expression positive. Okay, you can take any example. Suppose I take a value less than 2, suppose I take 1. So it is 1 minus 2, so that's minus 1. It is 1 minus 3, that's minus 2. So minus 1 into minus 2, that's greater than 0. Okay, so and suppose I take any value between 2 and 3, suppose I take 2.5. So it is 2.5 minus 2, so that's 0.5, and 2.5 minus 3, that is minus of 0.5. So that's a negative value. Okay, so if you want this expression to be positive, then you need to see the upper portion of the number line. Okay, and if you want this expression to be negative, then you have to see the lower, the below, the portion that is below number line. Okay, so here what is the solution set? X belongs to from minus infinity to union 3 to infinity. Okay, because we want greater than 0, so we will not include 2 and 3. Okay, so x, if x belongs to minus infinity to 2 or 3 to infinity, then this expression will always be positive, right? And if x belongs to 2 to 3, then this expression will be negative. Okay, so that is very simple concept. That really doesn't matter when whether x minus 2 and x minus 3 are getting multiplied, or one of them is in the numerator and other of them is in the denominator, right? The solution set will be same. Okay, I take some more examples. Similarly, suppose I have x minus 2, x minus 3, x minus 1, x minus 3 upon x minus 2, right? Similarly, you just draw the number line, mark the zeros in ascending order. Start from this direction, this. Okay, now if you want this expression to be greater than 0, then you just see the portion that is above number line, so that is 1 to 2. So x belongs to 1 to 2. Then you see 3 to infinity, union 3 to infinity. Okay, so that's it's very simple. If you put any values which is more than 3 over here, you'll be getting a positive expression, and if you take any value between 1 and 2, still you will get a positive expression. But if you put up any value between 2 and 3, this expression will be negative, or if you put up any value less than 1, still this expression will be negative, right? So that's very easy if you solve the inequality using wavy curve method. Okay, if it is greater than 0, if it is instead of greater than 0, if it is greater than equal to 0, then nothing else would happen. You just have to put a square bracket over here, nothing else. Okay, and infinity will never have a square bracket because infinity is never included. Okay, so this is how you can solve this problem very easily. And one more example, suppose I take you are having maybe x plus 1, x plus say 2 by x minus say 3. Okay, so zeros will be here, minus 1, minus 2 and 3. Okay, just be careful. X plus 1 is if I put x is equal to minus 1, it will be 0, x is equal to minus 2, it will be 0, and x is equal to 3, it will be 0, right? So minus 2, minus 1 and 3. Similar manner, you just draw the curve. If you want it to be less than equal to 0, then what is a range? That is x belongs to minus infinity to minus 2, because this portion is below number line. So minus infinity to minus 2, you want equal to sign, that's why minus 2 will be included, right? So from minus infinity to minus 2, this entire expression will be negative. Similarly, minus 1 to 3, so I will put a union over here, and minus 1 to 3, this expression will be negative. So in this entire range and in this entire range, this entire expression will be negative. Okay, so I hope you are getting it. Now we have one more type of inequality when we have modulus function, okay, or expression in modulus sign. Now you know what exactly it means. Suppose you have maybe modulus of minus 2, so that it will be equal to 2, that you might have studied in your functions chapter. Okay, so modulus means it converts, the modulus sign converts any expression to a positive expression. Okay, so suppose we have any expression, maybe suppose x minus 2, it is in modulus. Okay, then the inequalities, how do we solve, how do we present on a number line? Let's see. Suppose modulus of x is less than 2, right? I just draw a number line. Now this is minus 2, this is 2, right? Now modulus of x is less than 2. That means x should be between minus 2 to 2. Why? See, between minus 2 to 2 we have, suppose I take only integral examples, we have minus 1, 0, 1 and 2, right? If you take the modulus of minus 1, it will be positive 1. If you take modulus of 0, it will be 0. If you take modulus of 1, it will be 1, right? So all the three will produce modulus of x less than 2. Right? If x is a data, that is a number that is less than minus 2, suppose it is minus 3, right? So if you take modulus of minus 3, it will be 3, and that will be greater than 2, not less than 2, right? So if modulus of x is less than 2, then x will lie between minus 2 to 2. That means x belongs to minus 2 to 2. Okay. Similarly, if modulus of x is greater than 2, then what will happen? This is minus 2, this is 2. In this side and in this side, right? You'll be getting the negative values over here, minus 2, minus 3, minus 4, minus 5. But if you take the modulus of all these numbers, you'll be getting the value greater than 2. Right? Similarly, if you have all the positive values, maybe 2, 3, 4, 5, 6, and if you take modulus of them, you'll be definitely getting the value that is greater than 2. Right? So x should be either less than minus 2 or it should be greater than 2, right? So if modulus of x is greater than 2, x belongs to minus infinity to minus 2 union 2 to infinity. So these are the results that you have to keep in your mind. It's not at all difficult. You should be conceptually clear why it is happening. Do not go for rectification. You should be conceptually clear, right? And if it is equal to sign over here, then you just convert the brackets like this. Nothing else. Okay. Now apart from that, suppose you have modulus of x minus 2 greater than 3. Okay. So again the same thing. That's minus 3. I suppose take first of all less than 3. And this is 3. Right. Now this expression you just consider as 1x only, or maybe you can say it is y. Right? So this particular expression as this same, right? In this case, x minus 2 should be greater than minus 3 and less than 3. You can compare this to this. Okay, here x minus 2, mod x was greater than 2. So x between mod x is less than 2, then x is between minus 2 to 2. Similarly, if mod of x minus 2 is less than 3, then x minus 2 will be greater than minus 3 and less than 3. After that you can easily solve it. Suppose x minus 2 is greater than minus 3, that means x is greater than minus 1. Right? But this entire expression is considered to be one single element, you can say. Okay. Similarly, mod of x minus 2, suppose it is greater than equal to 3. So you draw minus 3 over here, 3 over here, right? So modulus of x minus 2, this and this way, right? So x minus 2 should be less than minus 3, less than equal to minus 3, and x minus 2 should be greater than equal to 3. Right? Now you solve both the inequalities, and whatever the answers you are getting, all the answers you have to mention. Okay? Because in both the cases, in this case and in this case, right, this inequality will be satisfied. Okay? So do not go for any sort of formula. You should be conceptually clear whether it is x minus 2 or whether it is x plus 2. Okay? If it is x plus 2, put x plus 2 over here. Okay? And solve it as you are solving. Okay? The very regular method. I have mentioned all the formula or relations over here, but it will be difficult to learn, difficult to remember. So if you are conceptually clear, you don't have to learn even a single formula over here, right? As I have mentioned, modulus of x is greater than a. You just draw a number line, put minus a and a, right? If modulus of x is less than a, that means x should be between these two. Right? If it is less than equal to a, then you will be making the square bracket. In this case, you are making the circular bracket. If it is greater than a, then that's minus a, that's a. You will take the values more than a and values less than minus a, right? Quite similar. If instead of x you are having x minus a or maybe x plus a, everything will be same, right? So no need to thus mug up all these relations. You should be just conceptually clear. Okay, I just take a simple problem so you can understand the concept or the rules how do we solve an inequality. Now it is 2, 3 minus x is greater than equal to x by 5 plus 4, right? You just open up the bracket. 6 minus 2x greater than equal to x plus 4 into 5, that is 20 by 5. You take LCM, right? If it is expression over here that involves a variable, then you cannot go for the cross multiplication. If it is a constant value, then you can go for the cross multiplication, right? In the last session I just told you this thing time and again, that in case of inequalities you should not go for cross multiplication if there is an expression in the denominator. That means the expression should involve a variable, but here in this case there is no variable, so no problem, we can directly go for the cross multiplication. So it is 5 into 6, 30 minus 10x is greater than equal to x plus 20, or we can say x plus 20 is less than equal to 30 minus 10x. Okay, so take 10x over here. So 10x plus x is 11x is less than equal to 30 minus 20, or we can say 11x is less than equal to 10. That means x is less than equal to 10 by 11. That means x belongs to minus infinity to 10 by 11 included. Okay, so very simply you can solve a linear inequation. It's really very easy. Okay, now friends, here in this case x minus 1 upon x plus 3 is greater than 2. Now you can see there is an expression in the denominator that involves a variable, right? So you have to be careful while solving it. You cannot go for the cross multiplication. So it is x minus 1 upon x plus 3 minus 2 is greater than 0. Take LCM. X minus 1 minus 2 into x minus 2x minus 2 into 3 is minus 6 upon x plus 3 is greater than 0. Okay, so it is x minus 2x, that is minus x, minus 1 minus 6 is minus 7 upon x plus 3 is greater than 0. I take minus common, then x plus 7 upon x plus 3 greater than 0. If I change this sign, the sign of inequality will also be changed, right? So if I put x plus 7 upon x plus 3, it will be less than 0. Now you can solve using Viveka method, right? Here I'll put minus 7 and here it is minus 3. I have to mark the numbers in ascending order, right? So minus 7 and minus 3, these are the zeros of this expression. We want it to be, this expression to be less, that means x should belong, x should be between minus 7 to minus 3. Okay, we want just less than, not less than equal to, so both of them will not be included. In fact, in any case minus 3 will not be included because that is the expression in the denominator. It should not be 0 in any case, right? So this will be your answer. X should be between minus 7 to between minus 7 and minus 3. Now similarly, if you do not follow this method, right, and if you go for the cross multiplication, see what happens. In this case, x minus 1 is greater than 2x plus 6. Okay, I just multiplied 2 to x plus 3, so it is 2x plus 6. So 2x plus 6 is less than x minus 1, right? So x is less than minus 1 minus 6, that means x is less than minus 7. Right, here you are getting x is less than minus 7 and here you are getting x is between minus 7 to minus 3. That means x is greater than minus 7 and less than minus 3, right? So there is a huge difference between both the answers, not difference, but both the answers are opposite to each other. In this case x should be less than minus 7, and in this case x should be greater than minus 7 but less than minus 3. Okay, so be very clear, never ever go for the cross multiplication in case of inequalities when you are having a variable expression in the denominator. Okay. So friends, I hope you are clear with the concept of linear inequations. From the next session, we'll be solving problems, we'll be taking simple problems as well as problems based on modulus, and then we'll be taking word problems as well, and how to solve inequalities using graphs, that also we'll discuss. Okay, and we have yet to discuss the solution of inequalities when we are having two variables. Okay, so in the coming sessions we'll be discussing all this. Do revise this session in the previous ones. Bye bye.